By the end of this lesson, you should be able to determine the specific latent heat of fusion, LF. Solve problems involving specific latent heat of fusion. Observe the images. Which way is better to cool the drink? By using the container of ice cubes or cold water. Covering the tin can with ice is the better way of cooling the drink. Why does putting the drink in the container of ice cubes make the process of cooling the drink faster? When ice melts, a large amount of heat is absorbed before it turns into liquid. This lowers the temperature of the drink. Observe the temperature. The temperature of the drink remains the same, regardless of the outside temperature, until the ice cubes in the glass totally melts. Are there any changes in temperature once all the ice cubes have melted? Yes, after all the ice has melted, there is an increase in the temperature of the drink. During the phase change of ice cubes to water, there is no temperature change. After all the ice cubes have melted, the temperature begins to rise. Why does this happen? Click on the Start button. What happens to the ice cubes in the experiment? At B, the ice starts to melt. At C, it has completely melted, and all the ice, solid, has been converted to water, liquid. BC on the graph is a mixture of solid and liquid. At BC, heat absorbed is used to overcome the strong bonds between the molecules in order to change from ice, solid, to water, liquid. At C, heat absorbed is used to increase the kinetic energy of the molecules of water, and thus the temperature rises. A glass of water is put in a freezer. A thermometer is used to record the temperature. Observe the changes in the temperature. What happens to the water after some time? The water in the glass becomes ice. The amount of heat required to melt the ice is the same as the amount of heat released when water solidifies to become ice. The amount of heat required to convert 1 kilogram of ice to water is defined as the specific latent heat of fusion of ice. Specific latent heat of fusion equals to quantity of heat, joule, over mass of solid, kilogram, equals to Q over M. The SI unit for specific latent heat of fusion is joule per kilogram. Latent heat of fusion is given by the equation Q equals M times LF. To convert 1 kilogram of ice at 0 degrees Celsius to 1 kilogram of water at 0 degrees Celsius, 334 kilojoules of heat must be absorbed by the ice. Conversely, when 1 kilogram of water at 0 degrees Celsius freezes to give 1 kilogram of ice at 0 degrees Celsius, 334 kilojoule of heat will be released to the surroundings. Therefore, the specific latent heat of fusion of ice at 0 degrees Celsius is 334 kilojoule per kilogram. An iceberg has a mass of 10,000 metric tons. How much heat is required to melt the iceberg, initially at 0 degrees Celsius, and bring the resulting water to a temperature of 6 degrees Celsius? Take the specific heat capacity of water as 4.2 kilojoule per kilogram per degree Celsius, and the specific latent heat of fusion of ice as 334 kilojoule per kilogram. Heat required equals the sum of heat to melt the iceberg and the heat to raise the water temperature. Therefore, the total heat required equals 3.6 times 10 to the power 9 kilojoule.
In this activity, we will carry out an experiment to determine the specific latent heat of fusion of ice. Measure the mass of the calorimeter and stirrer, M1. Drag the copper calorimeter and stirrer to the weighing scale. The calorimeter is then filled with warm water. What is the mass of the warm water? M2. Drag the calorimeter with warm water to the weighing scale. The water is stirred carefully, and the temperature of warm water and calorimeter, T1, is recorded. Ice cubes that have been dried with paper towels are added until the temperature reaches 10 degrees Celsius below room temperature. The temperature of the ice-water mixture, T2, is recorded. What is the mass of the mixture of ice-water now? In the determination of the specific latent heat of fusion by the method of mixtures, ice that has been dried is placed in a known quantity of warm water in a calorimeter. After complete melting of the ice, the equilibrium temperature is measured and the mass of ice is obtained by weighing the mixture. The heat equation is solved for the specific latent heat of fusion of ice. The heat lost by warm water and calorimeter is equal to the heat gained by ice and ice water. Thus, latent heat of fusion of ice is 82 calorie